Okay, so just like when we try to use equality property of logs, sometimes things don't work out. Same thing can happen with the equality property of exponents. Here we have two exponents, but their base is not the same. Okay, one's base 4 and one's base 2. So I can't use my equality property the way it's written. Now, there is a cool trick where you can change the base of the exponent. If you want, you can watch the video that will link to this one. But generally speaking, it's easier just to do this trick of taking the log of both sides. Okay, so before we do that, I want to show you a problem that we worked on before a couple lessons ago. So 4 to the x equals 16. I can solve that by taking the log base 4 of both sides. So I'd have log base 4 of 4 to the x is equal to log base 4 of 16. And I did log base 4 because the base of the exponent is 4. And what's going to happen here is I can use my power rule that x is going to come out front. I'll get x times log base 4 of 4. And log base 4 of 4 is just 1 because you multiply by 4 one time to get 4 to the first power, right? So this is x times 1, which is just x. And so that is going to equal, if I went back here and kept track of everything, it's going to equal log base 4 of 16. And I could just type that in my calculator, or I can realize that that's 2 because 4 times itself twice, 4 to the second power is 16. So I have my answer that x equals 2. Okay, now that worked because my log had the same base as the exponent. Okay, so that worked on this idea that logs are inverses of exponents. So I'd like to use a similar rule here, but the problem is I don't know what my base should be. Should I use log base 4 or should I use log base 2? Or does it matter? Could I use a different log? So I'm actually going to do 3 versions of this. Okay. The first version, I'm going to take log base 4 of both sides. So log base 4 of 4 to the x equals log base 4 of 2 to the 4th power. Okay. In the middle one, I'm going to take log base 2. So I'm going to do log base 2 of 4 to the x equals log base 2 of 2 to the 4th. Okay. And then for the last one, I'm just going to pick a base. I'm going to do log base 10 just because I want to. Okay. And we'll see if any of these work and which one we should use. So let me finish writing this down here. Log base 10 of 2 to the 4th. So we're just taking log of both sides, and because we're not sure what base to use, we're just trying 3 different ones, and we're going to see what happens. Okay. So on all of these, I can use my power rule to bring these exponents out front. So this one's going to be x times log base 4 of 4. And even on the other side, this 4 is an exponent that can come out front and be 4 times log base 4 of 2. Okay, so now that I've got this, I can get x by itself by just dividing both sides by log base 4 of 4. So I'm going to divide this by log base 4 of 4, and that'll cancel this out. But I got to do it to the other side too. So I'm going to divide this by log base 4 of 4. And so that gives me x equals 4 times log base 4 of 2 divided by log base 4 of 4. Okay, now let's do this one. So again, the x is going to come out front. I can do x times log base 2 of 4. Remember, we're doing log base 2 on these ones. And then on the other side, the 4 is going to come out front, and I'm going to have 4 times log base 2 of 2. Okay, now I can get x by itself by dividing both sides by log base 2 of 4. So I'm going to divide it on both sides. and it will cancel out here, and I will get x equals 4 times log base 2 of 2 divided by log base 2 of 4. Okay, now on this last one, same thing. The exponents come out using my power rule. So we got x times log base 10 of 4. And that's going to equal, the 4 comes out, so 4 times log base 10 of 2. And to get x by itself, I'm going to divide by log base 10 of 4 on both sides. So you can see this is pretty repetitive. I'm getting very similar answers. The only thing that's different is the bases that I'm using. So this one's going to give me x equals 4 times log base 10 of 2 divided by log base 10 of 4. And so now the question is, what do these give me, and are they right? So to see what these equal, I'm going to use my calculator. Okay, so here we go. So the first one, we have x equals 4 times log base 4 of 2 divided by log base 4 of 4. So let's type that in. 4 times log base 4 of 2 divided by, okay, now see how that messed up my fraction. It actually doesn't matter, but if you want, if it makes you feel better, we can type 4 times up there. Then on the bottom I got log base 4 of 4, and that tells me that the answer is 2. So this is saying that x equals 2. Okay, now let's do the same thing, but now I'm going to be using log base 2. So actually I'm just going to go here, I'm just going to change my base to 2 on both my logs. So I got 4 times log base 2 of 2 divided by log base 2 of 4, which is what I have here. And hey, look at that. It also equals 2. So this equals 2. And for my last one, we had log base 10. So 4 times log base 10 of 2 divided by log base 10 of 4. So I'm going to change these to 10s. And look at that. It still equals 2. And it actually doesn't matter what you put here for your base. This will always equal 2. So yeah, it's kind of a cool property of logs that they behave that way. And if you watch the video that we linked to in the beginning, you can kind of see why does this happen. And it basically happens because we're changing the base of these things to make them equal. Okay, so encourage you to watch that video if you're interested, and good luck.